Hi, welcome to Math After Hours with Miss Austin. I'm a licensed math teacher here to help you with any math questions you might have. Today we are looking at the composition of functions. So let's just dive right in. The first thing I wanted to do is just go over a few basic examples. You've probably seen something like this before, f of 3. So we are given that f of x equals 3x plus 4. If they want us to find f of 3, that means we're going to take this 3 and replace x with 3. So then we would have 3 times 3 plus 4. That's 9 plus 4, which is 13. Now we don't have to just plug in a number. We could plug in a function like x plus 2. If they want us to do f of x plus 2, now we are going to take this x plus 2 and substitute that in for x. So we still have the 3, but instead of x, now it's x plus 2, and then we still have the plus 4 on the end. So this is 3x plus 6 if we distribute in 3, plus 4. So simplified, that's 3x plus 10. So a composition of functions occurs when one function is put into another. So technically what you just did right here was you took this function x plus 2 and you plugged it into another function, which is f. But some of the time it's not written this way. A composition of functions can be written two ways. One is like this, f of g of x. What this means is you're taking the function g and plugging it into f. It's also written this way, f of g of x. So this is an open circle, and this is saying the exact same thing as this over here. We're taking the function g and plugging it into f. This open circle is not to be confused with multiplication. I have students that do that a lot. They mix up these two. If the circle is closed, then you are multiplying. If the circle is open, that's when you're doing a composition of functions. I personally like it better written this way. So if it's given to me like this, I'll usually rewrite it this way because it's just a little bit more visual on what's going on. So we have two examples here. F of x equals 2x minus 3, and g of x equals 5 minus 2x. So we want to do f of g of x. So like I said before, I usually rewrite this. So this is the same thing as f of g of x, like this. So I like to rewrite it. The next thing I'm going to do is just replace this g of x right here with what g of x actually is. So since g of x is 5 minus 2x, I'm just going to write that in here, 5 minus 2x. Now this looks like the example we did above, where we did f of x minus 2. We're just going to take this 5 minus 2x and plug it in for x in f. So it's just a little substitution. We'll still have the 2, but now x is being replaced by 5 minus 2x, and then we still have the minus 3. So distributing in 2, that's 10 minus 4x minus 3. And then combining like terms here, that's negative 4x plus 7. Okay, so that's how we put one function into another. Now on part B, we have f of g of 3. So rather than a function, we have this constant 3. We actually already found f of g of x, just barely. So we could just take 3 and plug it into that function. But sometimes you don't already have that function, so it's easier to just do it from scratch, and that's the way I'm going to show you right now. So if we want to do f of g of 3, that's f of g of 3, if I just rewrite it like this. What I want you to do is work from the inside out. So we're going to find g of 3 first. G of 3 means we're just taking 3 and plugging it into g right here. So So that's 5 minus 2 times 3, which is 5 minus 6, and that's negative 1. So now we know that g of 3 is negative 1. I'll go back and say now we have f of negative 1. So we're just substituting this back in for this g of 3. And we'll find f of negative 1 by plugging negative 1 into the function f. And that is 2 times negative 1 minus 3. That's negative 2 minus 3, which is negative 5. Okay, so that's how you do a composition of functions with pretty basic linear functions. Now I'm going to just show you 2 more examples with a slightly more complicated function. So down here, f of x equals x squared plus x minus 1. So now we're dealing with a quadratic. And then g of x is linear, that's x plus 6. So we have f of g of x that we're doing first. If I just substitute in what g actually is, then I have f of x plus 6. This x plus 6 right here is going to replace x in f. We're going to substitute it in. But if you look at f up here, we have multiple x terms. So both of these will need to be replaced with x plus 6. So when we rewrite this, it will now be, instead of x squared, it's x plus 6 squared. And then plus x plus 6, replacing x with x plus 6, and then we have minus 1. And then it's just about simplifying from here. X plus 6 squared is x plus 6 times x plus 6. You are not just squaring both of these terms, you have to multiply it out. And then we have plus x plus 5 if I combine the 6 minus 1. So this is x squared plus 6x plus 6x plus 36 plus x plus 5. So finally, combining all the like terms, we have x squared plus, that will be a 13x if we combine all the x terms. And then a plus 41 if we combine 36 and 5. So the answer for this composition, f of g of x, is x squared plus 13x plus 41. This last one over here is g of f. We are using the same functions, but you will not get the same answer if you go the other way around. This time we're plugging f into g. So if we do that, I'm just going to replace f with what f actually is, which is x squared plus x minus 1. So we're going to take this whole thing in here, and we're going to substitute that in for x in g now. So instead of having x, it's x squared plus x minus 1, and then we still have the 6 on the end. So our x got replaced by this, we still have the plus 6, and then we can just simplify it by combining these two. That's x squared plus x plus 5. And that is how you find a composition of functions. I hope that was helpful. If you have any math questions you would like me to do, please comment them below, and please like and subscribe.